Introducing DataWeave transformations. The DataWeave transformation language is a universal, simple, JSON-like language for transforming and querying data. It's easy to write, easy to maintain, and capable of supporting simple to complex mappings for any data type. It supports XML, JSON, Java, CSV, EDI, fixed width, flat file, and COBOL copybook out of the box, and it's extensible for new formats via an API. It is more elegant and reusable than custom code. Data transformations can be stored in external DWL files and used across applications. This example DataWeave transformation shows how simple these expressions can be. On the left, you can see a JSON input, and on the right, you can see an XML output. The top part of the DataWeave language is the header that contains directives. These are high-level pieces of information about the transformation. Below that, in the body, you'll see a DataWeave expression that generates the output structure itself. DataWeave expressions are going to provide an expression that is a data model for the output. It's not dependent upon the types of the input and output, just their structures. It's against this model that the transformation itself is going to be executing. The data model of the produced output can consist of three different types of data. One is objects represented as collections of key value pairs, arrays that represent sequence of values, typically comma separated, and simple literals. The output directive is going to set the output type of the transformation, specified using content type, such as application JSON, text JSON, and so on. The structure of the output is defined by the DataWeave body itself, and that's what you see below the directive on the example on the right. Now let's talk a little bit about setting input data MIME types. When you run your application, you could get an error unless the MIME type for the input data has been set. It may be set automatically if the data is posted to the flow, so you can look inside of your inbound properties content type, or you can define the input metadata type as you have been doing throughout class. A third option is you can set the MIME type property of a preceding message processor. As you can see in the bottom right here, this is where we're explicitly calling out the MIME type of a processor before calling it out as application JSON. Now, one of the questions is, where exactly is the code? Now, one of the great things about DataWeave is it's just like other Mule code. And what I mean by that is rather than having a completely different descriptor language that got stored in some weird file that you really couldn't read from a human perspective, this is something that can get placed right inside of your XML in a C data block, as you can see inside of here in the highlighted area. Now, a lot of times you don't want to muddy up your XML with complex transformations. So you can add this information as well in an external file, as you'll see. Additionally, if you have sample data, it is stored in source test resources. As we saw in a previous module, this ensures it doesn't get packaged with the final application bundle, since it's just used at design time. Now, as I was mentioning earlier, if you want to reuse transformations, you can place them in an external file. To do this, you can click the Edit Current Target button and set the source code to file. The transform is then saved as a DWL file, and DWL files will be stored in source main resources, which is of course packaged with that final bundle to ensure when the application starts up, it can ingest that and get the instructions it needs. Then to reference an existing DWL, say you had a new transformer that you were putting in place, but it should use the same DWL file you used elsewhere, you can specify it in the code. As you see here, all that you need instead of putting that big C data block in is the mention of resource in set payload, which then can point to the DWL file in your class path. Now, what if you want to create multiple transformations in one message component? This is also possible. So if you'd already written a transformation for the payload, you can then go to the plus sign to add a new target. And from there, you can then choose what that output target will be. So say along with the payload transformation, you want to do some JSON transformation into a variable, or some JSON transformation into a property. You can then switch between these multiple transformations by clicking the little drop down that in this dialog currently says payload, and flip between your different scripts. Now let's get into walkthrough 10.1, write your first data weave transformation. In this walkthrough, we'll create a new flow that receives post requests, and we'll write a data weave expression to transform the data to Java, XML, or JSON, add a sample data and use live preview, and finally save the transformation to an external file. Let's get started. Let's start off in Anypoint Studio, and inside of APDev Flights Web Service, we'll open up our implementation XML that we've been working in throughout class. All right. Let's now drag a new HTTP connector from the palette to the very bottom of the canvas. So we'll search for HTTP and drag that to the bottom. From the bottom, let's change the name of this flow so that it is named Post Flight Flow. We'll double click on the HTTP listener, and inside of the HTTP listener, let's set the path to flights. And let's set the allowed method to post. With flights and post in place, we'll also add a logger to the very end of the flow for our own debugging purposes. With the logger in place, let's add a transform message before the logger. With transformation in place, we'll right-click and add a breakpoint to it since we'll be doing some debugging shortly. We'll make sure that transform message is selected so that we can see the properties view down at the bottom. Now, let's go ahead and delete the existing curly braces that you see inside. And let's put in payload. So with this setup, we can see our output is going to be application Java, and right now the only thing that we've expressed is payload. Now as a reminder, if you double click on your HTTP listener at the beginning, we're exposing this on a place we've already exposed our app on, but specifically listening for post requests. Take a moment to scroll all the way to the top and select the main HTTP listener you were using in the last module. Let's also verify, and this may be blank for you, let's also verify that allowed methods is set to get. So if it's blank, put in get. This ensures that they will not conflict with one another when it starts up. Now, once you've made this change, let's save our implementation. And inside of source main API, let's go to the api.raml file. Inside of the api.raml file, let's find the example for posting to flights. So if we search inside of our file, we'll eventually come upon the example JSON body for post. Let's copy this to our clipboard. And once you have this copied, let's run the application in debug mode. Once the application is started successfully, we're going to head into Postman to do a quick request and see exactly how it behaves. So let's go to Postman. And inside of Postman, let's construct a request such that we are doing a post request. Specifically, let's call out to the flights endpoint without any query parameters in place. We'll start by going to headers and ensure that in the headers box you are specifying a content type in which the value is application JSON. And finally, in the body tab, be sure to paste in that JSON content you just copied. Now, with the JSON copied in and our headers in place, we should be looking pretty good to get a request sent out. So let's hit send, and we'll return to Anypoint Studio. Now inside of Anypoint Studio, we can see that an HTTP request came in, and we're stopped on our breakpoint. If we go to the Mule debugger, we can see at this point in time we have a Grizzly utils buffered input stream or buffer input stream in place. Now if we look inside of the inbound properties, we can see that the content type is set to application JSON. Let's now step over to the logger. And now that we're on the logger, if we look inside of the payload box, we can see our MIME type is application Java. And inside of the payload, we clearly have some type of map. Great. Now let's click the resume button one more time. This will send the response back to Postman, which we're not too concerned about at the moment. Now let's change the output data type to JSON and see what happens. From transform message, we'll switch from application Java to application JSON, and we'll save this change. Now, since it is still running, it should start up once again with debug mode enabled, and we're going to send the same request in through Postman. So once it has restarted, we'll return to Postman and send the same request. Once you sent that request in, we can return to Anypoint Studio and once again see that we're stopped on this breakpoint. We'll now go back to the Mule Debugger tab and step forward on top of Logger once again, this time with the desire to transform into JSON. Now the big thing you'll notice that's quite different here is we now have the MIME type of application JSON, and clearly the type is significantly different than what we had seen before. It's now this byte array seekable stream. If we select the data type, you can see it's not printed out the same way a map would be. Now let's step all the way to the end of the application and then return to Postman, and we can see that that JSON body was in fact returned. Now, back in Anypoint Studio, what if we change the output type one more time? So in this case, let's go to application XML. We'll save the application up. Once again, go back to the console and validate that it does have a successful restart. And then we'll return to Postman and send the same request through one more time. Back in Anypoint Studio, in our debug mode, we'll step forward once again. So from the Mule Debugger tab, we'll step forward to the logger, but this time we'll see that an exception was thrown. Now, let's see exactly what happened. So in the exception thrown box, we'll select here, and we can see trying to output second root flight code. So clearly there's some type of marshalling or some type of exception in its ability to actually achieve the transformation. Let's now click resume and push it all the way through till it exits the application. And we'll return back to the implementation XML to figure out what's going on. Now, if we double click on transform message, we'll investigate this a little bit further. But for now, let's just switch back from application XML to application JSON. We'll now click the preview button inside of here, and it will say create required sample data to execute preview. Let's click this. All right. In the sample data types argument dialog box, let's click the word unknown under metadata. And let's drop this box down and set it to JSON. We'll now click the button under actions. And in the select metadata type dialog box, we'll click the add button. In this case, our type ID will be flight_JSON and click create type. We'll drop down the type choice, and instead of simple, we'll choose JSON. And instead of schema in this case, let's choose example. We'll now click the browse button. And from our application under source test resources, let's find the flight-example.json file. We'll select this and hit open. Now we should see the data structure load up, and we will hit select. Now we can hit OK in our box, and we've got some preview metadata from the left showing up after transformation in the right. With our preview data in place, let's now switch the output from application JSON to application Java. Right when you do this, you can see the structure on the right completely shifts. We can now see the linked hash map being created and some of the fields and their values inside as well. Now, what if we go back to XML where we were having issues before? We'll go to application Java and switch it over to application XML. Now with this in place, you'll notice nothing happens to the transform and an issue shows up. If we hover on top of the issue or click, you'll see a similar statement to what we saw in our runtime exception, which was that it could not find that output second root or trying to output to the second root. So effectively, it wasn't able to marshal into the XML or satisfy a transformation to XML. Let's hit OK. And from here, let's go back to Java one more time. We will come back to this XML just a bit later. As you'll see, the structure of XML, due to its slight differences, will require us to type this out a bit differently. All right, now that we're back inside of Java format, let's go ahead and switch over to the XML view in our application. If you scroll down to the bottom of the application, you'll notice that our script is in place here, the data we've transformed, the input payload, and the actual transformation itself, which is set payload, and this is of course containing our transformation. Now, if we go back to the message flow view and double click on transform message once again, we can edit the current target button using the pencil. So let's click on this. Now inside of this dialog, we're going to switch from inline, which means in the XML, to file. We'll call this file JSON_flight_playground and hit OK. Once you've made this change, graphically, things will look pretty much like you've seen before. But if we go back to the configuration XML and go to the bottom, you can see we're no longer putting the script in line. Instead, we're storing it inside of source main resources and keeping a reference to that right inside of here. In fact, if you go into source main resources on your app, you should now see that this DWL file is being stored there respectively. Let's now save the file and pause here and talk a little bit more about different transformation data structures.